Today we are going to be looking at our sine and cosine graphs again, but today we're going to be looking at translations and reflections, it says, of them. So we will be moving our graphs. So we're going to be considering the same things as yesterday in terms of shape, amplitude, and period of our graphs, but there may be shifting involved in one direction or another. So, considering the same things we thought about yesterday, this first problem is a sine graph. So its shape would be middle up, middle down, middle. What is the amplitude going to be for this one? Remember, amplitude is determined by the multiplier of the trig function. So what would that be? 3 is what is multiplied by sine. So 3 will be the amplitude. Okay, the multiplier of the trig function is what determines the amplitude. So it says 3 times sine. Yes, there's other stuff up there. We'll talk about that in a minute. But the amplitude is determined by the multiplier. The period we talked about yesterday as a rule is 2 pi divided by b. What is b in our equation? The multiplier of x, which is 4 in our equation. So we get 1/2 pi for our period length. Now there is a part of this equation that we haven't thought about yet, and that's the new part for today. That -2 in the front is going to move our graph down 2 spaces. In addition or subtraction to the equation, whether it's happening in the front or the back, will be a vertical shift in the direction it says. So -2 goes down 2 spots. If it's a positive value, it would go up the number of spots. So when we create our axes, I'm going to put my axis up a little higher than we did yesterday because I know I'm going to have to move this thing down, so I'm going to give myself some extra room to move it down here. The first thing we take care of in our graph is a shift that happens. So what I'm going to do is go down 2 spots and make myself a dotted line that I can use as a guide. That line is going to be our new middle. So when our pattern says middle, instead of being right on the x-axis like it was yesterday, it's going to be on that line. So in addition or subtraction to the graph moves the middle line up or down. Now we can do our scaling like we did yesterday, taking 3 lines of paper, turning it on its side, and calling it a pi. And I actually only need to go to pi on this one. Yesterday I said that I would like you to include 2 patterns, and if the period is pi over 2, then this is all going to fit within 1 pi. This is a very squishy graph. So I'm also going to put a marking in there at 1/2 because that's where the period length ends for 1 full cycle. So now we're ready to plot some points. Sine begins in the middle, and that is on that new shifted middle line. Then at the end of the period length, which is pi halves, it ends in the middle. In the center, it's in the middle. In between those, we have an up of 3 and a down of 3. And repeat that shape one more time. Arrows and tails on the end to show that it does go on forever. And yesterday we talked about how this could relate to sounds and musical notes. So we said that the height represented what? The height would be a change in volume. So this is, we would kind of consider 1 normal. So this is taller than normal, so it'd be louder. And that the period length represented the tone. Would this be a high pitch or a low pitch? Yeah, a high pitch. The faster the vibration, the higher the pitch. Okay, so graphing the same as yesterday. The difference is that we may need to move our middle line here up or down if we have an addition or subtraction to the function. Next example, cosine. What was the shape for cosine? Up, middle, down, middle, up. What is the amplitude in this equation? 1/2. It is the multiplier of the trig function, so that 1/2 in front of the cosine gives us our amplitude. The period is 2 pi divided by what? Pi. So we get just 2. So that means when we go to do our scaling, we're not going to care where pi is. We'll just scale by ones. The one piece of this graph that we have not done anything with yet is the 3. What is that going to do to our graph? Go up 3 spots. So that means when I make my axes here, I'm going to make my axis low because it needs to go up 3 spots. So I take that midline and bump it up 3 spots above where I put my x-axis. I'm going to do my scaling, taking 3 lines of a paper and tipping it, but instead of calling it pi, I'm just going to call it 3 because I don't care where pi is since the period has a value of 2. Or you could just take 1 line of paper and tip it and call it 1. But we just want to scale by ones here. Or if you're working on graph paper, then each box just has a width of 1. Now we're ready to plot points. Cosine starts in the up position. The amplitude is 1/2, so I'm going to start 1/2 above the middle line. At the end of a period, which is 2, cosine is up again, so above the 2, I'll be 1/2 above the middle line. In the center, cosine is down, so above the 1, 1/2 below the middle line. And right in the centers of there, we have our middles. So it's all nice and symmetrical. And repeat the pattern over once more so we see 2 full cycles. Again, on cosine, make sure when you do your tails and arrows that those are pointing downward to head into another repetition, not going upward. The graph should never go up above those up points. Those up points should be the maximum height. Questions? The font did some strange things here, so I will rewrite this equation. Said y is equal to 2 cosine of 2/3, and then it doesn't like parentheses, so it turns them into weird symbols. But this is what your equation should look like. So let's break it down. Cosine has what shape? Middle down, middle up. Amplitude is what? 2, the multiplier in front of the cosine. Period is 2 pi divided by b, where b is multiplied by x. What's multiplied by x in this equation? That 2/3. It's outside of the parentheses, but we could distribute it in. So that 2/3 is a multiplier of x. How do I divide by 2/3? Multiply by 3 over 2, so that gives me a period then of 3 pi. Now the one part of this equation that we haven't used yet, we used the 2 for the amplitude, the 2/3 for the period, but we haven't done anything yet with the x minus pi fourths. This is not going to shift our graph up or down because it is connected with the x. When our addition or subtraction is happening with parentheses with the x, that's going to shift according to the x-axis. So it's going to shift sideways. We've talked about sideways shifts earlier this year. What's different about sideways shifts? Which direction will this shift? To the right. So x-axis shifts happen backwards of vertical shifts. So vertical shifts do what they say. So if this is -2, we go down 2. If it said up 3, we went up 3. but horizontal shifts go opposite of what they say. So when it says x minus pi fourths, we move to the right pi fourths. So create my axes. Before we can do shifting, we need to think about scaling because we need to know where pi fourths is to do some shifting. So I'm going to take 3 lines of paper and tip it and call it a pi. And if I want to fit in 2 cycles, I need to go out to 6 pi. Take care of shifting before you do any point plotting. I need to move over pi fourths, or 1/4 of pi. So I'm going to take that pi and break it into 4 pieces so I know where 1/4 of pi is. And I'm going to bump that y-axis over 1/4 of pi. And that gives us a new starting line. So vertical shifts, up-down shifts will give us a new middle line. A sideways or horizontal shift will give us a new starting line. Now, when we go to think about our measurements, if that axis bumped over, then all of these markings that we've made need to bump over a little bit as well. So I'm going to put a 1/4 mark in past all of our markings. Now we're ready to plot some points. Cosine begins in the up position at a height of 2 on that shifted starting line. Then at the length of a period, which should be 3 pi away from where we are, so not above the marking that says 3 pi, but above the marking that shifted from the 3 pi, we should have another up point. So that it's 3 pi away from the beginning. So all those markings needed to bump over one spot. Then halfway between will be down, and you can just kind of eyeball these, or you could actually count it out if you want to be really precise and figure out where they would be. And then we repeat the shape. 3 pi away, so at the marking past 6 pi, we should have our up and the center down, and then going through the middles. Horizontal shifting is the trickiest that we will be talking about today. So when we do a horizontal or sideways shifting, it comes from something being added or subtracted in parentheses with the x. It goes backwards of what the equation says. And we shift that starting line and then shift all of the markers for our units along our axis. So all of those pi's needed to shift over as well. Questions? Let's try another one with a horizontal shift. Okay, so this is sine, the shape of sine. It's middle up, middle down, middle. What is the amplitude in this equation? 4. Amplitude is the multiplier in front of the trig name. The period is going to be 2 pi over b. What's b in this equation? 3. So the period is 2/3 of pi. This one's going to be really squishy. So we use the 4, we use the 3, but we have not used the plus pi thirds. What is that going to do? To the left pi thirds. So that means when I go to make my axes, I'm going to give myself a little bit more room on the left-hand side than I have been, since I'm going to have to bump back in that direction. Take 3 lines of paper, tip it, and call it a pi. But I need to go backwards pi as well this time since I have to do some backwards shifting. I need to shift by 1/3 of pi, so I need to break these pi's up into 3 pieces. And shift back 1 of those pieces. Then I'm ready to plot points. Sine starts in the middle, so on that shift line. Then at the end of one period length, it should end in the middle. The period is 2/3 of pi. Each one of these little tally marks on our axis represents 1/3 of pi. So if I want to go 2/3 of pi away, I need to go 2 markings away. In the center, sine is in the middle. And between we have an up and a down with an amplitude of 4. And repeat that pattern over one more time. Again, a period length of 2/3 of pi puts us 2 markings away for the end. The center, up, and down.
It's only 2 pi over 3, so where do we end?
The first one ends 2 markings away from where we started, and then the next one ends 2 markings away from that because each mark represents 1/3 of pi. So we're going 2 of those 1/3 marks. Questions on horizontal shifting? We have one more type of change that we can make to our graphs. So this is a sine graph. What is the shape of sine? Middle up, middle down, middle. What about amplitude? There's a -3 there. Amplitude yesterday in our notes, we actually didn't really focus on this because it didn't matter yesterday, but amplitude is defined as being an absolute value. Since it's a height, we always want amplitude to be a positive number. So amplitude is still going to be 3, but that negative is going to make a difference. What that negative is going to do is flip our graph upside down so that ups will become downs and downs will become ups. So a negative reverses the pattern of ups and downs. So ups become downs and downs become ups. But our amplitude is still defined as being a positive value, so our amplitude is still +3. Period is 2 pi over b. There's nothing in front of that x, so we say there's a 1 there, so 2 pi over 1 or just 2 pi. So on our graph, we need to scale out to 4 pi. And our pattern says we're going to begin in the middle. After one period length of 2 pi, end in the middle. In the center, be in the middle, but flip from normal, so it is going to go down 3 first and then up 3. So it is an upside down sine graph. And then repeat that same shape one more time. So a negative in the position of the amplitude still gives us a positive amplitude value, but changes all the ups and the downs in the pattern shape. Questions? going to do one more example, but I don't want to do this one. So I'm going to change this last problem. Y is equal to -2 cosine of 1/2 parentheses x minus pi halves plus 1. This equation has everything in it that you could encounter. So it's like the pinnacle. If we can do this, we can do anything. So first thing, cosine has what shape? Middle down, middle up. The amplitude of this graph is what? 2, but there's a negative. What's the negative do? Flip that shape. So down, middle, up, middle, down. Period is 2 pi divided by what? Divided by 1/2, which gives us 4 pi. So I'm just going to have one cycle of this one. Then stuff that we haven't dealt with yet. What does that x minus pi halves do? Shifts it to the right 1/2 of pi. And what does the plus 1 do? Up 1. All right, whoops. So get some axes drawn on here. Figure out my scaling. Take 3 lines, tip it, call it a pi. And I think you have enough room on your paper to do 2, but I don't, so I'm just going to do 1 cycle. You can do 1 cycle as well. And now we want to do our shifting. So we're going to go up 1 spot and put a dotted line that represents the middle. You don't have to put these dotted lines. They are not technically a part of the graph. They are just helpers, but I think they're pretty big helpers. So I kind of need them there for myself just to remind me of them. But if you don't draw them, your graph would still be correct. Then I need to shift forward 1/2 of pi. So where I have that pi marking, I'm going to go halfway and shift forward for a new starting line. And then I'm going to shift all of those other markings 1/2 as well. So I draw in all my other halves. We are finally ready to plot some points. Cosine for our shape, since it's upside down, is going to begin in the down position. 2 spots below the middle line on our new starting line. So where those 2 dotted lines are meeting, that's kind of like our fake origin for this problem. Okay, so 2 spots below that intersection of our shift lines. Then at the end of 1 period, which should be 4 pi away from the start, so that is at the half marking past that 4 pi, it's down again. Halfway between, so that's at the marking past the 2 pi, it would be up. And in the middle of those, it's on that middle line.
Wait, why would we go down to?
Because the amplitude is 2. So whatever the amplitude is, that's the height that we need to be going past the midline. So this graph had absolutely everything that could happen. It had an amplitude change up to a height of 2 instead of 1. It had a period change with that multiplier of 1/2. It had the negative, so it flipped. It had a shift sideways, a shift up. So this graph did everything. Questions on it? Your homework is from 14.2 to